So here we are on the catwalk of the Joides resolution. This is the area where all of the scientists gather and the technicians bring in core sections in 10-meter sections as they come up. They come up to the drill rig, the technicians bring them in, they lay them out here and we get a first look at the core. It's then cut into sections and taken inside to the core lab where we split it. So let's go and check it out. So after the 10-meter cores are brought up onto the catwalk, they're split into 1.5-meter sections by the technicians. They're capped, then they come onto this rack and they're left till they equilibrate with room temperature. Then after that happens, the next thing is that the core sections go on this physical properties tracking system, which measures things like magnetic susceptibility, gamma ray attenuation, and that gives us the first measurements on the cores and tells us something about the composition of the sediments. So after the core sections go through the physical property tracks, they're brought into here, which is the core splitter. They're split into an archive half and a working half. Core description and non-destructive measurements are made on the archive half. Then the working half is laid out on the core sampling area, and scientists come and take subsamples for various measurements. So after the core sections are split, the working half of the core comes in here and is put on this sampling table. And then the various different teams of scientists come and mark the places where they want to take samples, or they start taking those samples. So here we've got markers for people who are working on paleomagnetism, people who are looking for ice rafted debris, all the different types of analysis. The paleontologists will take samples, and I'll take samples for biomarker analysis, because somewhere in this core, although we can't see them, we know there's going to be molecular fossils that were deposited at the time this sediment was forming in the Eocene about 40 million years ago. It was a greenhouse world where there was no ice on Antarctica, and we're hoping that those biomarker fossils, we're going to be able to extract them. They're going to tell us something about the environment and the temperature of that greenhouse world. Let's take a sample and saw it up and get it ready for biomarker analysis. Don't try this at home, kids.
And then after this we go
down to the chem lab. So after I've taken my sample from the working half of the core, it's wrapped up in aluminium foil to protect it from contamination. It's labeled, entered into the database, and then the samples are taken down here and put in this chamber, and this chamber is connected to this freeze drying unit, and what that does is it sublimates off all the ice and traps it, and it dries out our sample and gets it ready for crushing and the next stage of preparation.
You've got your cup of tea, James.
Yes, I've been looking for this all morning, and coming down to the freeze dryer has been good because I've managed to locate my official IODP tea mug. And being English, I like to have a nice cup of Earl Grey. After the sample has been freeze dried, we're ready to homogenize it. We need to turn it into a powder. So we take our freeze dried sample and we add it into this little chamber here. Then we transfer the sample to a test tube like this, and it's ready for extraction.
Hi, my name is Stephanie and I'm the microbiologist for this expedition, but today I'm helping James with his biomarkers. So last I think you were with James and he crushed his sample up. And then I'm going to take the samples, I add some solvents, this is DCM and methanol. I try to mix the samples up using this here, this vortexer, and then we put it in the centrifuge for a couple minutes, and what we end up with is a sample that has sediment on the bottom and then the liquid organic layer on the top. And the lipids are here in this organic layer above from the sediment. So then we just add this extraction to a previous beaker that I have going here using a funnel that has been baked at 460 degrees for at least 6 hours. All right, we've now brought our sample down to the chemistry lab. And as you can see, we have a whole bunch of liquid on here. The lipids are in here, but pretty diluted, so we need to evaporate the liquid off. We do that using a rotovaptor. That takes a while, but luckily I've already done it to a previous sample. Over here we have a sample that I've already evaporated, and I've actually already added some water to it. And you can see the water's dirty, and we really need to separate the lipids from the sediment. So we do that by doing a liquid-liquid separation. As you can see now, we're starting to get two different layers in our flask here. We have the organic layer and the water. So there's actually many different kinds of lipids in here. We have alcohols, we have fatty acids, we have tetraethers, and we want to separate those out so we can analyze them all individually. And to do that, we use a column. Now this is a silica column that we made here on the ship, and using this glass pipette, we can take out our organic layer and put it onto the column, which will slowly drip into different vials depending on the solvents that we use to run through. And that way, we can get everything nice and separated. We then transfer the biomarkers to smaller vials, and these are the vials that we put onto our auto sampler, man's best friend. All right, well here is our auto sampler, and the reason we call it man's best friend is because to look at these lipids, it takes a long time to run each one individually on the gas chromatogram, about 70 to 90 minutes, and we really don't want to stand here that long and wait for it to end. So we just put a bunch of samples on, and the needle automatically injects everything for us. All right, and then we get this beautiful report. And as you can see here, we have many different lipids that have been separated, and we even have long-chain fatty acids, which derive from plant material that was incorporated into the organic matter as it settled out and was delivered to the bottom of the ocean and then preserved for millions of years.
Hey Steph, how's it going?
Oh, thank God you're here. It's going good, but
Yeah.
I'm ready to be done.
Tired?
Yeah.
Okay, good. So Steph's finished her analysis. Time for me to take over for the next 12 hours because the organic geochemistry in the chem lab never stops.
Hello, my little British friends.